dig in a bit deeper. This is what I like. It's what I live for. Anyway, we've got this big flat network where every pod can see every other pod. And it's fabulous, right? It really is. But pods, they're ephemeral. They come and go. So this bunch of pods here, right? I don't know, imagine they're serving an internal search API for an app, yeah? Well, right now we've got 2 and each one's got an IP. And then, of course, we've got other components of the app in the cluster that are using it. However, if demand ramps and you scale the service, each time you do, you're adding new pods with new IPs. Then when you scale back down, you're taking them away. And the same goes when nodes fail. You're losing pods with IPs. Sure, I mean Kubernetes recreates those failed pods on other nodes, but those come with new IPs. So how does everything else that's wanting to use the search API here keep up with which pods exist and are healthy? Enter services. Now, there's actually quite a lot to services, but at their core, they're a stable abstraction point for a bunch of pods. So what we do here, right, is we create a service object and we logically put it in front of the pods. Then, at a high level, we say, you know what, instead of trying to hit individual pods down here that can come and go, hit the service instead. And obviously, the service is clever enough to handle all the churn and the stuff going on with the pods behind it. But that's the gist, right? Okay, but how does it actually work? Well, for starters, right, every service gets a name and an IP. And there's a couple of things to note about the name and IP, right? Firstly, they're stable. Kubernetes guarantees that once you create a service, its name and IP will never change for its entire life. Sweet. That solves the reliability issue of pods. Second though, the name and IP gets registered with the cluster's built-in DNS or add-on DNS, yeah? So every Kubernetes cluster has a native DNS service. I mean, you might have to manually start it, okay? But every cluster can have a native DNS service, and every pod in the cluster knows how to use it. So in the example on screen, right, it means every single pod in our cluster can resolve search API here and reach the service. It's beautifully simple. Well, that sorts out the front end of the service. Think of services, as load balancers or proxies. They've got a front end config and also a back end one. Well, on the back end, it needs to know which pods to send the traffic onto, yeah? Well, we do that with a label selector. Now, this example's saying, okay, balance traffic across all pods in the cluster with this label here. And you know what? We can list multiple labels and what have you, right? But this is the basic config. This is the name and the IP on the front and maybe a port as well. Hit me on this. And when you do, I'll balance your traffic across all of the pods in the cluster with this label. Which again is cool and all right, but how does the service actually know which pods are alive and kicking? Well, I'm glad you asked. You see, when you create a service object with a label selector, Kubernetes also creates another object on the cluster called an endpoint object. And what that is a list of pod IPs and ports that match the service's label selector. So, in our example, the endpoint object for the service will have 3 entries, one for each of the 3 pods, yeah? But the cool thing? The service object is always watching the API server to see if new pods that match its selector are being added or removed. And as they are, it automatically updates the list in the endpoint object. Right, so the endpoint object itself always has the same name as the service object it's associated with, and it is a list of pods that the service can send requests to. So, a client makes a request into this front-end config of the service, and then for the service to know how to forward requests on, instead of doing some on-the-fly lookup to see which pods on the cluster actually currently match the label selector, it just picks one from the endpoint list, because it's always up to date. simples. Now then, services are powerful and there's a lot to them. So, coming up in the next lesson, we're going to take a look at the 3 major types of service.